Hi everybody, good morning. Finally got time to do this room. I hope I can explain it. Explain it is a bit not that easy when you do encryption, especially the last one, the Chosen-Plaintext Attack. But let me try my best. I hope I can do it easy to understand. So attacking ECB Oracle. The principle is simple, just the way when you do the Python script. But even the principle, you need to understand it how it works. So this rule is about learn about the Electronic Codebook ECB Cipher mode and how to exploit its weaknesses. Let me put some text bigger. So there's some rooms in TryHackMe you can follow. Yeah, I'm not sure if it's too much useful, but it's good to have a cryptography one, or at least you know what is cryptography before you jump to attacking USB straightforward. This one is subscribers, so that's another story. Okay, this is, you can read what it is, the basic, the most important for us. They talk about the history here, for example, standard active means rotating encryption data, not equally all of that, and then we have the most important one is 1997. Encryption heavily in keeping the algorithm secret. This is the old days. Usually the security of the cipher should not depend of the algorithm. Algorithm should be public. It should be only about the ciphertext and the key. So even if someone got the algorithm, doesn't make any easy for them to find it. Um, the main concepts are now accepted as guideline for encryption. The confusion for an encryption are going to be secure. We must sufficiently obscure the relationship between our original plain text message and the encryption ciphertext. So basically, if I give you the ciphertext, you can't really guess anyway. There's no pattern. There's nothing that give you an idea how the plain text should be. That's the confusion. Diffusion. To assist with creating confusion between the two, it is a really good idea to spread our parts of the original plaintext before being transformed into ciphertext. Key only reliance, that's exactly the key. So you can't say you have a secure algorithm and you hide it. The only thing that matters is the key. Is the encryption can only start to be deemed secure if you can freely distribute the algorithm that we used, as without the key the ciphertext can't be converted. So you can't just hide and say I develop a new algorithm very secure, but you're hiding it. No, the security should only depend on the key. And this is how IS advanced encryption standard started by Regional Cipher. Of course, and here talk about encryption symmetric and asymmetric keys. Um, because either you need one key for encryption decryption, or asymmetric because you need one key for encryption and one for decryption. The next competition to find, I think this one is this 97. Let's go through the first task because we'll spend more time in the cipher attack. What is the IS cipher, otherwise known? This known by the name of the creator Ranger cipher. And then we have what type of encryption IS. IS is symmetric, so if you did Computer Security Plus or something, you know that. Now the code, the cipher blocks, the cipher working blocks. IS was, for example, working 16 blocks. TryHackMe gave us something. Let's copy this IP. I didn't do it yet. Um, this first one is more introduction. So where is you? Where are you? I think it's port 5000 if I'm not mistaken. So we have ECB or encryption, decryption, and we have the Oracle later on. So we have the encryption part. So basically here is the idea of the block. Cipher work in blocks, like for example it encrypting blocks not by bytes. Not all of them, but for our case, this is why I refer to as block cipher, because there's block cipher and there's the, well, the old one they call it bit cipher or something, that bit by bit. Because most, as I said, most of the messages are not rarely have the same, like 16 16 16. So you add the TryHackMe room, basically they simplified with adding stars. So if there is no enough, like for example you have 15, they add 1 star. If you have 14, they add 2 stars, and things like that. The Cipher mode, of course, is plenty. You have the key encryption algorithm and all of that. Now they explain it here. For example, if you have block 1, block 2, block 1, for example, cryptography, whatever, they have block 2. Of course, when you do encryption, you convert to bytes. So you have bytes where you have 2 2, you can 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, which means this one is 16. 1 2 3 4 5 6 7 8 9 10 11 1 2, so that's 16. And then we have perform the encryption, the ciphertext for block 2, create and final output, because the block cipher they mix them together. So ECB they put them together, so you have this one next to that one. And of course they tell you in Python how to do the encryption. So basically, for example, if we do what we have here, the plain text, we have the secret key, this is the decryption. So we have the plain text and the mode ECB. So for example, yeah, visit this one encryption and enter the text cryptographic circuit with the super password. Let's do that. This is just introduction to the important part later on. So if you go with the super things, then it give me the result. It's a block, and you can know it's 16 because if you copy this, let me paste it here. Where is that? 32 1, let me check. 32 32, yeah. Oh, no, the encryption. Why is a padding? What's wrong with TryHackMe? Yeah, this is 31. Yeah, there's 16 blocks. So the result is 2 blocks. You will notice that the cipher look completely random, but as you will discover in the next task, ECB is very insecure cipher. So basically this one is very simple. We will instead more of this when we start doing that. That's why I didn't want to spend too much time on this. IS is a cipher block, which means that the text will be broken down into fixed site blocks to be converted into ciphertext. What is used when the last, this one we call it the padding. So we need to add padding. In our example, they simplify we just add in stars. So for now, it's fine for us. What is this? No, this one they just want you to practice um, with with the tool using what is the encrypted message. So if I go there, what did I do? What the hell I did? Oh, I forgot. Now we no, not this one. No, here we start with a simple simple to explain how ECB is not really secure. Here we go into we have the room here. We have CD rooms ECB. We go to task 4. uh, here we have a test BMP image. The idea here is we're trying to encrypt this image. So this image, can we open it? BMP, it should open fine. Let's go to desktop. Where is that folder? Rooms, ECB, where are you? ABCDE, ECB, task 4. So we have this image, so we have the test. So the idea, I want to encrypt it with ECB. So now let's use ECB to encrypt this message to make it easier to view the data again as an image. We are going to cheat slightly and preserve the header of the file. So yeah, basically this is just a proof of concept. So head might see the header test. So they're now saving the header. So we're just taking it to taking the first 54 character. Tail minus C, the tail of it. Okay. Okay, let's copy that and we can check it now. So this is the part where I preserve the header, the cheating part of TryHackMe. So we have this test ECB BMP. We did it with the OpenSSL, what is the key. Now if I go to our folder here, and if we open that, you can see you still see it. You can see TEST. So basically this encryption didn't really work. So notice how even through the data is encrypted, it's still possible to view the message. And that's one of the ECB, because especially for images, is not really working well. So let's go thread solver. What cipher principle does ECB not perform? Remember, we talk about the principle here. We have confusion, diffusion. In this case, it's diffusion. If I'm wrong, I'm right. To assist with creating confusion between the two, it is really good idea to spread out part. No, not diffusion. We're able to read the or before transform the ciphertext. So it's really good idea to spread out part of the original playtest before being transformed into the ciphertext. So you think that's what we didn't do. This attack has been double the ECB Penguin attack, because it showcased on the Linux tax Penguin. On the attack box you can find, okay. We can demonstrate by encrypting the cartoon image. Cartoon tend to have region where all the color are the same, and that's what the block ciphers, and hence we'll encrypt the same when using the block cipher. The most famous cartoon is this. You can see. Okay, so it's not diffusion. What type of file are notoriously difficult for us to be encrypted? This is image. I'm not sure with an S or just an image. Okay, with an S. Here where the things start become more complex, interesting. Now here where the whole things. So the idea, let's start. For example, let's go to our. Sorry, no, I don't want you. what happened here. Now let's go to CD task 4, task 5. They give us a script. Now we have here, let's start it very carefully to start. This is the assumption. The assumption, for example, if our ECB use, for example, secret called TryHackMe, and you have username. This is an example of this room. Usually, for example, when you have an Oracle, for example, I can put my username. If you submit, it tell you result. Now, the idea is we need to find the secret. The secret in this case is like, for example, TryHackMe. So now, for example, if you're using a username in A, you have this result. Then you have this the idea of the blocks. The idea is to keep adding letter A, because, for example, here until you jump to another block, and you keep adding to jump another block, and then you compare the result, and you can see, for example, if you have to the idea is looking for two blocks with to A, because ECB will encrypt same blocks the same way, because it doesn't that's where insecure come from. The best way to do this, to understand it and not confused, let's go straight to our system. For example, here I said, so we have a full block of A, so we know that the idea is after adding the fifth, we jump to second block. We jump into the second block, so the cipher creates a second block. Then we keep adding A, it jump again to second block. So it jump in the fifth. This is of the fifth letter. 1, 2, 3, 4, 5. It jump to create second block. And then after 21, so 8 is 16, then 21, we have a second block. So 21 minus 5 will give you 16, so we know the block is 16. The next part is how to know the offset. The offset is basically looking for the key, the secret. So you start pushing the A's. This is the A's we're trying to push. Push them one by one until we have two blocks of A's. And how you know? Because you know they encrypted the same way. You can find 16 blocks, 16 blocks, and then you know this is exactly your secret. You're looking for. And then after you do that, then what you do, you minus an A. You don't send this A. You keep this, and then if you don't send this A, that letter T will come here, which is basically here. And then you brute force it, because we know all of it, we just don't know one of them. Then you brute force in, if then you find the character, and then you minus an A. Each time you keep the B's, and you minus the A's. Each time you minus the A, the letter R come down, the T go back here, and then you look for the R, and then you bring them one by one. So let's practice this logic in our case. So now, for example, if I say letter A, I get this. So let's practice this one so we don't get confused. Let me remove this, it's not ours. So this is our first block, and you can see is 64. So we have it's a bit larger. So before we jump and say what is it, let's do what we need to be done before we jump. So now we keep adding letter A until we see the jump. So now it's not jumping. I'm not sure it jump, but let's add 2, 3, 4, 5, 6, 7, 8, 9, 10. Still not jumping. I think it jumped 1, 2, 3, 4, 5, 15. Still not jumping. Let's make sure it's not. There is no new block added. So this one still not jump. Then we get another one. Now you jump. So if you go there. So now it jump. You can see it jumping. then it jump in what? Let's copy this so we know it's there. It jump in our case, how many letters I can see in the bottom here? It's 17. It jump in 17. So this one is 17. Let's do, because we don't waste time, let's make this is 17, 17, 34. Let's make 33. Now it jump in 33. Let's make it 32 because to make sure. So 32 it doesn't jump. 33 it jump again. So if you go there, let's go there. Now it jump. It jump on and this one is 33. It jump in 33. So we can say 33 minus 17, which is mean we are in 16 block cipher. So the block is 16. Now dun, 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 dun. You jump in 16. So we have a 16 block. Then we have, however, we want one byte of the actual data in the block that we control. So in our case, we can do the following. So 16 plus 4 minus 1. Oh, we find this the 4. The 4. I forgot what I'm supposed to do now. So we have a 33 jump. If I'm not mistaken, now we know the jump is happening here. Now we need to push our A's to go to offset. How many offset we need to add? So if you add 1B, now we are not going jumping enough here. So let's say, I think it's, let's not waste, but it's still not 3. I think it's 11. Let's do 10. 3, 4, 5, 6, 7, 8, 9, 10. Still not jumping. 11. Which key I did do now? Oh no, I'm confused. If I do 10, for example, let's make sure. If 10, this is 10 B's, huh? Because trying to push the A's so we get offset. With 10B we get this one. Remember we have 16 block. Let's block this one to 32. Remember we're talking about bytes, so that's 32. So we drop there, drop there. Oh, we already found it. It's very strange. It's 10. I thought it's 11. Because you can see these two blocks are the same, so it means our oh no, we don't. How many B's are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I solved this room, supposed to be 11. Now I'm getting confused. With 11 B's, okay, for 11 B's we got this. So if I drop this one down, otherwise I'm doing something wrong. It's still 11, it give me the blocks. This is the A's. You can see that the same. But why as for the 10 and 11 they're the same thing? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What I'm missing here? It jump in index 21. This means we must determine our offset to better understand which block of data we fully control. Taking a look at the image below, our username start close to the end of the first block and then flow into the following blocks. Yeah, however, how much 8 and 8, 16 and 8, 24, 20, 32 is sending 32 blocks. Oh, that's for my mistake. 32 for A's because I want the two blocks to be equal. How many A's did I send there? This room is sometimes it really confuse me. How many A's did I send? I sent 33. That's why I'm confused with 11 and 10. We need to send 32 because I want them to be 16 and 16 A's. So the idea, if I send two blocks of A of 16, 16, then I look if I find this equal together. That's why the confusion I have here. So if I go now, and let's say I go with a 10B this time, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10B. Let's make sure it's 10B. Let's delete this one. So we're looking for so we know the offset, so we're doing this. Let's make sure if I put the mouse the cursor there, it will tell me 10. So we have 10. If I send 10 now, I get this one. And if I break it down to 32, remember it's bytes. Oops. 32, so we break there. I break there. I break there. So they are not equal. You can see I don't see identical blocks. So if I go another letter B now, for example letter B, and send that, if I get now this, remember we sent 32 byte blocks. Because 16, 16, in theory we should have when Cipher encrypt them with the B's, should give me exact encryption, so we should see that in the result. And yes, we saw that. You can see these two blocks, so they are the same, and that's what it means. Our A, they encrypted the same way. So here and this we got it with by sending 11. So our offset is 11 in this case. So we know the block is 16 and we know the offset is 11. So that's very important. So basically that's it. So you send, because the cipher is 16 block, because it's 16 our case, we send 32 A's and we push the B's until 2 blocks will fill up with A's, and that's what we got there. So by pushing the B's to 11 we got 2 blocks the same. This is 2 blocks, which mean our B's now are all of them in the first block. So now what we can do after that, we do the brute forcing as the example it showed this. So each time we remove one letter, and now that's what you send. However, we went to 1 byte, so 16 like in our case is 16 plus 11 minus 1, and we get how many we sent. So in our case will be the block cipher is 16. I think what the hell? Plus 11. So now we get plus 11 minus 1, which we get, how much we get? 26. So we need to send 26, and every time, like in this case, we sent, I said send 19. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So you send 19, and then why you send 19? So you bring that letter back here, so you can see we're taking that down. And next time you remove an A and you push this, and then you brute forcing until you find the 2 possible, all of them. Now they give us a script. The script they give us TryHackMe is this one. Let's copy it before we messed it up. Let's make a copy so we know it's there. So if I go to ECB, so of course this is encryption. They give us the machine. So the machine IP is where do you have it? Is this one. Now we can run it to confirm what we've been doing. So we can say Python 3.9 ECB, no, cd room ECB task 5. So you can say Python 3.9 ECB, and you can see is what he's doing. He find the first letter O. So we have the first letter O. So and the same what we did, we have a 1733, we got it manually here. We said we find the first root as 17, we find the 13, we find block cipher 16, and we find that B11 we have the 2 identical blocks, which give us the block 16, and we have 11, and then a reference chunk is this. This reference chunk is simple. For example, if we how he got this, because if we remember our math here, we have we need to send 26 in total. So 26 will be, where is the so 26 how many B's are there? Sorry guys, this is 10 B's. Who is the one that we did now? 11 B's is this one. 11 busy mean is the key, the secret key is length 11. That's what we're looking for. Then we send 26. This is 26, so that's the broke down. Otherwise, I'm getting confused now. Let's go down. I'm trying to do it manually quickly so we can understand what's going on. Let's see what the script tell us. Script got this. That's our block. The middle one. You can see the same what TryHackMe is trying to do here. So you send the first one, and then the next one that you will send is like, for example, he found the letter O here. So what we do is no, we keep sending, and then we brought the O. For the next one will be sending less A, then a brute with brute force the O. Let's do this because so we don't get confused. Let's follow first what's happening here. The scripts, you can read them. The first one is to the first function was to interact with ECB. So basically they use the beautiful full SOP, this one. Follow Python, that's how we read when you contact that form, it sends you HTML, you need to read it. Calculate the logic for calculate the block cipher, the same logic we did, send A until jump in the blocks and all of that. Split the cipher and then calculate the offset. We did the calculate the offset by pushing the B's, and then we extracting the first byte. Will work in this function. Now let's first answer the first question. What do we need to determine the first step to attack ECB? The block size, cipher block size, and then what is the second element that we need the offset, and then what's the first character we got? It is letter O. Let's get now to that script to understand it. Our more interesting part is we're looking for the offset, extract first block bytes. This is, you see, it starts with initial text, that's initialization. Then we have the offset. Remember we said the B's, as we said, when we send it we keep always the same B's, which has 11. So we have this, we have the offset is 11, we set the B, and then the A's we minus 1 each time from the block size. So we have as we said here, how much we send here, 1 2 3 4 5 6 7 8 9 10 11 12 13 14. This is the second round, and this is the first round, so we need to send the full 1 minus 1, so it's 15. Then this is then send it to the form, split, get the chunk, the middle one, that's index 1. Let's do some things so we can, let's add some stuff here, we can see what we looking at. Return character, print reference chunk, string reference chunk. Let's also ask him to print me the text that he's sending so you can see what let's use the other print. I don't know why TryHackMe is using this thing. Use the text sent initial text initial and the text. Oh, sorry, we need to close that. If I'm not mistaken, this is the old way to do print in Python. Let's do that. Did he show the text and he only showed the chunk? I want to show. You can see now what he's sending. So now we can see the sending exactly. We know it's sending B's. So now how to get the second character and the last the other characters too. Now here's the tricky part. Remember what we said, the part of this one. When we find the letter T, we remove an A and we push that. So basically, if you understand the logic, so we can just say, okay, to find the second letter, for example, I just need to remove another A. So we take A out. We keep the B's the same, but because we found the text, now I'm getting confused. Before, but the text now we need to send for the brute forcing will be we need to put initial text plus equal the letter that we found the letter O. So basically this is like a small manual way to do it. Every time we keep the B's, we're not touching the B's, that's the key we're looking for. We minus letter, but because I minus letter here, I need to tell the system that what we found, because I'm not doing the loop yet. If things go well, I should get the letter number 2. And I got the letter number 2 is R. So now it's sending minus A, but I told him find I. So if I can say okay R, but I need to minus again here, so I need to tell him don't send another A, so I need to met there, and you can send that, and you found the letter A here, and you can see is every time he's sending less, so you can say -4 and then give it letter A here, and if I send that, we'll get the next letter number 4, a letter C. So I can put the letter C there, and I just send less letter A here. So if I go there, and then we can get letter L. So we know the letter L. So you can guess we got in the key. So you can keep doing this until you find the whole letter. Now you can say, okay, if this is work, because we just push in the brute force, we tell her because every time you remove the letter A, you need to replace what you remove with what you found. So now if we do this, you can say how we just loop it, because now I put L, I can go here to letter 6, and then we can just say, and I found the letter E. So 6 give me E. So what 7 will give me if I get Oracle. So you can see the key Oracle E. So if I put that, and I can get the next color is letter K. Any case, if we can do this, then the question is, because we know what we're doing here, we just put in the letter we want from the chart, and then the characters, and we minus. So the question is, why don't I have a loop here? So we can just say we can just say for I in range of the offset, but because we put in that I there, we need now to do the padding for Python, so we don't have all these errors. So we need to go, I'm not sure how to do it fast, let's do it one by one. Let's not complicate things. You can do it like we did, or we just create a loop if you want to make things automatic. You don't want to do one by one. So I hope I still remember how this thing works. This one is confusing a little bit. Uh, I forgot how to loop it now. Ay, ay. So we have the I, so we know that we need to each time to remove one I. That was -1 minus I. Remember it was -1 in the beginning. We keep the B's, we remove that, and then we need to define the characters. So we need to have something, let's call it string, for example, and let's call string equal empty string here. This is the one that we need to add. Remember, we need to remember this initial text that we have here. Now we can't say oracle, we can just say add string here, but we need to have the string to call. I'm not sure if it does work. I'm worried it doesn't work. So every time we find the characters, we add it to our string. So as we did the oracle, and then we add the string. If each character, we can push it to the initial text, and then we minus that. I'm laughing. Let's try. Let's see if it works in the first round. We did tell me some errors. Found character S. Oh, he found it, but the return should be not characters. I need him to return me the result, the string. He found the letters, but he's not returning the full name. Why? Dun, 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 dun. Oh yeah, don't return it one letter by letter. I think I'm mistaken here. The return should be in the function itself, not in the loop. Oh. Yeah, the letter is S. Found the character S. He finding all the character, I think. This is the function for I in range and offset. So the script is working fine. I just want him to give me the last answer. Return string. No, it's printing correctly. Test sent. The test send and the brute force work, and it give us all the characters. So that's fine. Found character need break at the end. Let's do the easy way. Just return string that side. Every time you found it, just return it. You know what? I'm getting confused for a moment. Let's do this. Let's say print. Let's do the F. Let's say string found so far, and then let's print string, and let's close that one. I think not return is confusing me for a moment. No, it's broken. I don't know what I did wrong here. It was working fine. Okay, now it's working. String font so far is Oracle. I think I'm messing up with the return here. It should loop return at the end. So now I hope you guys got it. So you can see every time we take minus and then we find the last one until we get all of them. So we got it, and you can see it's 11 characters. So this is the answer for this question. I'll come back now to the script. So basically, I hope you guys understand it. So every time we minus one character of the A, to force the secret to come to our block. So every time, and then when we find the T, we push the A down to the left, and then to bring the R down. So that's what we're doing here. Every time we do the loop here, we minus one letter A, we keep the B's, but when we brute force, we tell our function, the one that do brute forcing, we tell her what we found, because in our string we calculate them, collect them. This script you can make it nicer, because TryHackMe is doing something, I don't know why they're doing it that way, but sorry. We can do this. We can just say initial text plus equal. So instead to do this, we can just say $b multiplied by the offset plus $a multiplied by this, So in Python you can do this, you do multiplication like that, so you don't need to do these range things. So in one line of code you can just do the whole thing. So you can kill this if you want. So you can, all these things we can just put it in one line. This is to be better. So if I go now to my script, let's clear it again. Sorry, to make sure it's working. And now you can see it's working, so we can get Oracle knows. And you can see if you follow the script from the start, you can see always we send in the 11b, then the first a, and you do the brute forcing, then minus a, and you keep minus in a. So you can see every time we minus a, we minus a, we find Oracle, then you find that, then later every time you minus a and you push the other next character to you, and that's it. So basically that's a script. So if you want to make cleaner script, you can remove this, so you don't need this one. Initial text, initial b, offset block -1, refresh a chunk, and you can do this. Okay guys, we didn't finish. What left in this room? I hope I was able to explain. That's my best for now. If you see an ECB implementation, you should raise alarm bell. This might sound silly, but it has been found a white case let into the okay. Mitigation measure for secure coder. For developer, it is critical to ensure they are not using insecure cipher mode /ECB. That's why it's used because it means each block will be you don't when you have two same blocks, you don't have the same things. Yeah, this room took me time to really find an easier way to do it. For me, this is the simplest way. If you have questions, please let me know. And yeah, thank you very much, and have a good day.